Good morning, students. Today I am going to explain how to solve few problems on engineering mechanics in statistics of particle in two dimensions. So here, first read the problem. A string ABCD. So see the diagram. So a string AB, BC, CD. So totally fixed at 2 points A and D. So the 2 points, the symbol that shows that it is fixed at the point A and D, has two equal weights of 1000 Newton attached to it at B and C. So two weights. How magnitude 1000 Newton is acting on B and C. Weight is always acting towards down. The weights rest with portions AB and CD inclined at an angle 30 and 60 degree respectively, as it is given in the diagram. Okay. Find the tension in the portions AB, BC and CD. The portion of the strings AB, BC and CD, so we need to find the tensions. And also if the inclination of the portion BC with the vertical is 120 degree, it is given in the question. Okay. Let us explain how to solve this problem. So see the diagram. Okay, see the diagram first. So in the diagram, first we have to understand what are all the forces acting on it. So see this, first 1000 Newton weight is acting towards downwards. So when the weight is acting downwards, the string will act in the opposite direction. Okay, tension will act in the opposite direction. So see, at the point B, so we have 1000 Newton force towards down, and towards the up direction TAB is the tension in the AB. So when the weight is acting downwards, the rope will create a tension in the opposite direction. Okay. And in that BC cable, so in the cable BC also how the tension act towards right, towards B to C only the tension act. So see the point C. Okay, at the point C also, so when 1000 Newton force is acting downwards, the tension, the cable CD, the tension acts towards C to D. And also in the cable BC, the tension acts towards C to B. Okay. So we have TBC and TCB are there. So in a cable only one tension will be possible, which is equal. In a cable the tension will be equal. TBC and TCB are same, but opposite in direction when we are considering the point B and C. Okay, let us solve the tension. So as in the questions, we need to find the tension values TAB, TBC and TCD. So we have to find it. So how we are solving means, first we consider the point, free body diagram of the point B. So see the right side top diagram. So TAB, TBC and 1000 Newton force. So the angle between them. So first we need to find the angle between them. So here see the diagram. So 120 degree is given, right? So 120 degree. So after 120 degree, 30 degree will come, because alternate angles 30 degree will come. So the angle between them will be 150 degree, and in the left side angle come as 150, and also the remaining angle. So totally 120 degree. So the remaining angle will be 60 degree. So we find the angle in between the forces, and after that we solve the problem by Lami's theorem, because this is the particle at rest, right? So we can solve by using Lami's theorem. Lami's theorem, we know that Lami's theorem. Okay, Lami's theorem means we can apply Lami's theorem, means each force is proportional to sine of angle between the other two forces, considering TAB, right? TAB. So angle between other two forces is 60 degrees. So TAB by 60 and then TBC by 150. TBC alternate angle 150 and 1000 divided by sine of 150. So first we equate first and last terms. Okay, first and last term. So when we are equating first and last term, what we get is TAB is equal to, so bring sine 60 towards the right side. So we will get TAB value as 172 Newton. Okay. And then we equate second and second and third. So we are equating. So denominator both are same, sin 30, sin 30. So TBC equal to 1000 Newton, we will get 1000 Newton. Okay. So first section we completed. In the second section, draw the free body diagram at the point C, right? C. So here left side TBC is there, TCD is there, 1000 Newton is there. Also we know the value of TBC. Already we find in the previous session TBC as 1000 Newton. So we can directly substitute also. And also TCD value we need to find. So included angle, all the angles are 120 degree. We will calculating the angle becomes 120 degree. So here also we apply Lami's theorem. When applying Lami's theorem, we get TAB by sin 20. All the values are sin 20, 120. So denominator all are same. So numerator values are also same. TBC and TCD value are 1000 Newton. So like this we find the values. Then let us solve another problem. Okay, let us solve another problem in this. So here read the question first. So in the question, a cylindrical roller, right? A cylindrical roller has a weight of 10 kilonewton. So roller in the diagram, so roller is there. So the weight of the roller is 10 kilonewton. It always act towards downwards 10 kilonewton. And it is being pulled by a force which is inclined at 30 degree with the horizontal. So unknown value P. Okay, P. So this unknown value P value is we need to find. We need to find the value of P. Then while moving it comes across an obstacle 10 centimeter height. So when I am applying the force of P, what will happen? The roller will move up. So while moving, so one obstacle is there. The height of the obstacle is given in the question 10 centimeter. So it has to cross the obstacle. So diameter is given as 1 meter. Now we have to find the value of the magnitude of the force P that should be applied in order to move up. So here in this we need to understand that here the motion is impending. So due to the application of, still the roller is in equilibrium. Roller is not moving. What happened means due to the application of the force P, the roller just start moving up, lifting up by hitting on the point B of the obstacle, but it is not moving. So now, what are the forces acting on the roller? So first 10 Newton, kilonewton weight, it is always acting downwards. Then externally applied force P is there, it is applying. So then what are the other forces? So here reaction force, we consider reaction force. Reaction force will be generated at the contact point, isn't it? So here at the point B of the obstacle, right? At the point B of the obstacle, one contact is there. So reaction force will be created towards the center. Okay, reaction force always acting towards the center of the roller. Then we can have another confusion that as the roller is in contact with the horizontal surface, did we have the reaction on the horizontal surface? No, we don't have the at this moment At the horizontal surface, no reaction happens because the object is just lifting up. Just lifting up. There is no weight sharing on the horizontal surface. So here, horizontal surface, no reaction. Only at the obstacle side, only reaction R will be there. So here also we have three forces, right? One weight, one reaction and P. So this problem also we can solve by using Lami's theorem. So Lami's theorem, so we can apply, so force value P and then towards the point R is there. So I draw as away from the point R, then away from the point R, then downward force 10 kilonewtons. So three forces. If we find the angle between them means we can find the unknown by using the Lami's theorem. Okay. So here we need to find the angle. So one angle 30 degrees there, no, 30 degrees there, but we need to find the value of alpha. So how to find the value of alpha? So here just understand that how to find the value of angle alpha. So here you see in the question the diameter of the roller is 1 meter. 1 meter means 100 centimeter. Then what is the radius? Divided by 2. So it is 50 centimeter radius. Radius is 50 centimeter. Then height of the obstacle is 10 centimeter. Now we close the triangle. Okay, OCB. So triangle OCB. Now OB. What is the value of OB? Is the radius of the roller. OB is the radius of the roller, that is 50 centimeter. Then we can find the value of OC easily. How we can find means the total radius is 50 centimeter, right? Then height of the obstacle is 10. So remaining distance will be the value of OC. So okay, now the distance, the 50 minus 10 is equal to 40. So this is the value of OC. Now in this right angle triangle, now we can find the value of angle by using cos theta, right? Cos alpha. Cos alpha is equal to adjacent side by hypotenuse. So adjacent side is 40, hypotenuse value is 50. So while finding, we get the value of alpha as 36.87 degree. So okay. So as we got the value of alpha, so if this value is alpha, then this 36, when I am transferring this R towards away from the point, this alpha becomes this. Okay, angle between vertical and this force is 36.86. Now the total angle between R and P is the sum of 36.87 and 60. And the total angle between the vertical downward force, right? Downward force 10 kilonewton and P is the value 120 because here 30 degree is given in the question. 30 degree from the horizontal. So the 90 degree, 90 plus 30 is 160. So the remaining will be, from the 360 degree, we will get the angle between R and 10 kilonewton. So we got the angle values. Then angle between all the forces. Then by applying Lami's theorem, R by sine 120 is equal to P by sine 143.13 is equal to 10 by sine 96.87. Now we can equate first and last first. So thereby we got the value of R. And after that we equate second and last. We get the value of P. So this is the answer for this. Then we try to solve another problem. Okay, another problem regarding the roller. Okay, another problem on roller. So let us study the problem. Two rollers, each of weight 50 Newton of radius 10 centimeter, rest in a horizontal channel. Two rollers. So each are two identical rollers. Radius also given 10 centimeter radius. Two rollers are there, which is resting on a horizontal channel of width. Horizontal channel width is 36 centimeters. See the diagram, right? See the diagram. 36 centimeter channel. On that, two rollers are there. Find the reaction. find the reaction on the point of contact A, B and C. Okay. So then how to solve this? So here in this, so see the diagram. Okay, see the diagram. So in the diagram we can understand that two rollers are identical. That means same weight, 50 Newton and 50 Newton. It is acting towards the down. And consider the upper roller, right? The roller on the top. There, what are the forces there means first 50 Newton, right? 50 Newton acting downwards. Then wherever contact there, the reaction will be there. So first top roller having contact at C and D, right? Top roller is in contact with the point C and D. C means at the vertical wall. So the reaction will be there, RC. So the reaction will be perpendicular to the surface, RC. Then it is contact at the point D. So here also one reaction will be there. So roller, from the roller it reaction comes. So center to center, RD will be there, towards. So reaction always acting towards the point, right? So weight is acting downwards. So RD will be acting towards the point. Okay. In the second roller, consider the second roller. Second roller, so weight is acting 50 Newton, right? Then what are the contact points? At the point A we have contact, B also we have contact, and D also we have contact. So A means one reaction, vertical reaction. So reaction RA will be there, which is also perpendicular to the vertical surface. Then at the point B also we have a reaction RB. Okay, reaction RB also there. Then at the point D, RD already we find it from the upper roller. The same value will be acting, but it is in opposite direction. It is an action. So vertical. The top roller will give an weight sharing, that is RD, which is also reaction for the lower roller. Okay, so here also we have 4 forces. Then how to solve this problem? So for solving this problem, okay, here also equilibrium analysis. Okay, here also it is coming under equilibrium analysis. For solving this problem, so first solve the unknown values of the upper roller, right? So draw the free body diagram of the upper roller. So it is a free body diagram of upper roller. So here what are the forces there? 50 Newton weight, then RC is a horizontal force, and RD. So all the forces are acting towards the point. I am going to draw this acting away from the point. Then only we can able to apply Lami's theorem very easily. Okay. So I am acting away from the point. Then we have to find the included angles. Then we can solve it easily. So how to find the included angles? So for finding the included angles, so we need to find the angle of RD, angle of the force RD with respect to the horizontal. Okay, the remaining, the angle between RC and 50 Newton is 90 degree. We know that RC and 50 degree is 90 degree. So if we find the value of the angle of RD with respect to the horizontal means we will find the remaining 2 angles. So see the diagram. So for this I construct a small triangle, right? So small triangle in this. So the distance between the centers of the circle is 16 centimeter. So I got it because total width of the channel is 36 centimeter. So left side one radius 10 centimeter, right side one radius 10 centimeter. So remaining will be 16 centimeter. So center to center, the horizontal distance between center to center is 16. Then the hypotenuse value, radius of the roller, each 10 centimeter, 10. So hypotenuse of the triangle is 20 and adjacent side is 60. So now we can use cos theta, adjacent side by hypotenuse. So theta is equal to cos inverse of this. We got the value of theta as 36.87. So now we got the value of 36.87 plus 90 gives 126.87 and from 180 we subtract 336.87, so we got the value of angle between RC and RD. So we got all the angles. Now we can apply Lami's theorem easily. Lami's theorem, so first RD opposite angle 90 sin 90 degree, RC by angle between other two forces is 126.87, then 50 divided by 143.13. Now we can equate first and last, and also second and last, second and third. So while equating first and last, we got the value of RD. When equating second and third term, we got the value of RC as 66.6 Newton. So okay, so first roller, top roller, the value is unknown values we found. Then come to the lower roller. Lower roller, what are the forces mean? First, weight 50 Newton. So here two reactions are there, right? At the point A1, horizontal reaction, at the point B1, vertical reaction, and RD at the point D1 reaction is there. So RD value we already found from the upper roller, same RD value, the direction only changing. Okay, direction only changing, RD value, so 83.33 Newton. So here in this we have four forces, right? So we can't solve this using Lami's theorem. Lami's theorem we can solve only for three forces. So here we have four forces. So we can solve this with the help of principle of resolution of forces. So here for resolving the forces, we have RA horizontal, 50 vertical, RB vertical. So only RD only the inclined force. So RD we have to resolve into two components, one vertical and one horizontal. Horizontal component becomes 83.33 cos 36.87. Vertical component is 83.33 sin 36.87. Okay. So here we resolved all the forces in horizontally and vertically. So for equilibrium, we know that equilibrium condition sigma h is 0, sigma v also 0. So when applying sigma h is equal to 0, say here only two horizontal forces are there. One towards RA, towards right, so plus RA, and one towards left, so minus 83.33 cos 36.87. So from that we can find the value of RA. Okay, then sigma v equal to 0. Vertical component we have three forces, one upward, two downward. So RB only upward force plus, so minus 50 and minus 83 into sin 36.87, we get the value of RB as 100 Newton. Okay, so now we find the reaction at all the contact points in this problem. Okay.